Hello everyone, thank you for joining. My name is Satyum Joshi. I'm a technical specialist at FEV North America, and I will be presenting our study titled System Level Modeling Approach for Evaluation of Hybrid, Electric, and Fuel Cell Powertrains in Medium Heavy Duty Vehicles. I'd like to acknowledge all my colleagues who contributed towards this work, and also would like to thank Gamma Technologies for giving us the opportunity to present. So let us start with the motivation behind this study. We continue to see CO2 emission regulations get more stringent across the world. In the US, we have the greenhouse gas phase 2 emission standards that will require up to 29% reduction in greenhouse gas emissions by 2030. In Europe, this goes up to 30% reduction in CO2 emissions required. In China, we have the fuel economy standards that will continue to get more stringent. On top of these, we have some more aggressive regulations like the California Advanced Clean Truck Rule, which will require manufacturers to sell increasing share of near zero tailpipe emission vehicles starting 2024. So the key question is, how do we achieve these regulations? What's the technology that can help the products meet the requirements while making sure that the cost of ownership is maintained or potentially reduced? So one of the key enabling technology that can help achieve these standards and is also driving significant transformation in medium and heavy duty powertrains is electrification. However, it's important to point out that there is no silver bullet in electrification. The optimum architecture varies with application type, which tend to vary quite a bit for heavy duty applications. For example, a heavy duty Class 8 long haul truck would not benefit a lot from higher degrees of hybridization in comparison to, for example, light duty application where you're doing a lot of start stop and city driving, which can benefit from plug-in hybrids or full hybrids or even battery electric trucks. So the focus of our study was to evaluate what is the right architecture for a class 6-7 urban vocation application, which is most favorable from a hybridization and electrification perspective. We looked at mild hybrids, full hybrids, both series and parallels, as well as range extenders with a smaller downsized engine, and also battery electric truck and fuel cell truck. The overall objective was to understand what is the most optimum architecture for this application that would meet the regulation while minimizing the cost of ownership. So this slide shows all the tools that were used in this study. For multi-physics modeling, we used GT Suite. For all the DOE optimizations of electrified powertrains, we used Top Expert XCal, which is an in-house tool we've developed. For all our advanced controls implementation, if needed, we used MATLAB Simulink. This kind of workflow helps us in early identification of architectures and can also be used towards the later part of the program during product validation. So our start point was baseline model development for a Freightliner M2 truck. The truck had a Cummins 6.7-liter engine and an Allison 2000 series 5-speed automatic transmission. The model was correlated against test data that was collected on the truck via CAN. Fuel economy was correlated within 2%, and the key parameters for propulsion were correlated with regression above 90%. So then the next step was to integrate the electrified components of models into the baseline vehicle model. For the battery, we used an equivalent circuit model with one RC branch to capture the dynamics. For the motors and generators, we used map-based models with data coming from our testing at different voltages and different sizes of motors to create scaling functions. For the fuel cell, we relied on some data from the suppliers. The idea was to keep these models parameterized so we can vary them during a DOE run. So the first part of our evaluation focused on looking at near-term, less disruptive alternate powertrain solutions. And what I mean by that is we wanted to preserve the conventional diesel powertrain and use parallel hybrid concepts